I left you at the end of the last video with these three problems to work out. So let's just check that out. Okay. So for this one, we're starting with -2. We're supposed to plug that into f. Let's see. It's going to help, I think, if I just have parentheses around my x's, because that's telling me that's where I'm going to put my input. So this is just going to be h of whatever f of -2 is, because f of -2 is what's inside of those parentheses after the h. Okay. F of -2 is just going to be a -2 squared. So that's h of 4, and then h was the reciprocal function. So this would be 1/4. Next one, we had k of f of -5. So that's going to be k evaluated at f of -5. Now f, once again, was the squaring function. So I'm going to take my -5 and square it. So that's k of 25. And k is the square root function. So we're getting the square root of 25, which is 5. Now, you might notice here, what we just did is we squared something, and then we took the square root, and notice we did not get back to our original input since our original input was negative. We've seen that previously this semester. In fact, if I wanted to just come up with a formula for k of f of x, that's saying that I want to take k of x squared. Here, we're not being asked to plug in a number, we're being asked to plug in a formula to come up with a formula for this function composition. But what does k tell me to do? It tells me to take the square root of my input. So I'm going to take the square root of x squared. And we've discussed the fact previously this semester that squaring and taking the square root don't undo each other. So this gives me not x, but the absolute value of x, which is what we just saw in this particular example. All right, let's go ahead and try this last one. So this is going to be g of h of 1/2. Well, h is the reciprocal function. The reciprocal of 1/2 is just 2. So if you notice that, you can go right to 2. If you didn't notice that, we can still get there. If you literally copied this formula and put a 1/2 in the denominator, that's totally fine. That's just not simplified, because that's a complex fraction. We've got a fraction inside of a fraction. But I know that the way I would divide by a fraction is to multiply by the reciprocal. And so 1 times 2 gives me 2. I think it's simpler to just recognize that's the reciprocal function, and the reciprocal of 1/2 is 2, but notice it works out either way. Okay. All right, and then g was the function x plus 2, so that's just going to become 2 plus 2, and so that's 4. Okay, excellent. I'd like to get a little bit more practice finding the formula for a function. So we just did that with k of f of x. Let's do one more together, and then I'll let you try a couple. Let's take a look at f of g of x. Now, you'll notice I'm using this notation because I find it so much more user-friendly than the other notation. But you should be prepared for both. So if I had said evaluate f of g of x, the very first thing I would do is rewrite it as f of g of x. Okay, so let's see. That is f of g of x was x plus 2. And then f was just the squaring function. So I'm taking whatever's in parentheses after f becomes the input, and that goes in these parentheses here, because that's where the x was in the formula. That's going to be the thing that I'm squaring. And so that's x plus 2 squared. Now this is kind of neat because we've seen this sort of thing before. If I were to graph this, this would be a horizontal transformation. It would be a horizontal shift 2 to the left of the squaring function. So what function compositions do is they tell us to do more than one thing in a sequence. So in this case, we were supposed to add 2 and then square. Okay. And when what we're doing is just a simple arithmetic operation like that, we've already studied how that affects the shape of the graph. In this case, that happens to shift it. Notice if I were to do g of f of x, which I would immediately rewrite as g of f of x, that would be g of x squared. But g tells me to take my input and add 2, so that would be x squared plus 2. That would be a vertical shift, 2 up of the squaring function. So here, again, I'm doing the same two things. I'm squaring and I'm adding 2, but you'll notice the order in which I do them does make a difference. Okay, what I'd like you to do before the next video, so as we finish this one, before you turn on the next one, see if you can come up with a formula for h of k of x and for g of k of x. So I wrote this one using the notation that I think is not quite as user-friendly. So I would suggest that the first thing you do here is rewrite it in the more user-friendly notation and then go ahead and simplify the formula for it.